Welcome everybody. We're up here in Fairbanks. It's going to be a beautiful 70-some degree day here. And we have been very, very fortunate to be a participant in this NGDS program. And the main people that have worked on this are myself, Nina Heron, Cameron Hughes, and Cheryl Cameron. This picture here is a picture of Akutan Hot Springs out on Akutan Island. It's one of the areas that's actually being currently explored for potential geothermal energy. So the major focus of our contribution to NGDS has been the fact that we've had a lot of data here that was never in a digital format. There was a lot of exploration that went on in the late 70s and early 80s, and there were lots of paper records. Some of it was just company records. Some of it got published. And what we were able to do through this program was to take all of this data, compile it, put it together, locate some additional information that never had seen the light of day. And so what we came up with, and we actually came across, what did we find, 3 new geothermal springs through this process. So there's 97, there's records on 97 geothermal springs. We have 653 records on aqueous geochemistry, 121 records from 9 different geothermal wells. We were able to put all of the bottom hole temperature data we've been compiling from oil and gas wells into it. Cameron went through and got all the Holocene and younger volcanic vents and fumaroles. We gathered all the earthquake information, their hot springs, and we have detailed information on 15 direct use of geothermal sites. And as part of this process, we created a new geothermal sites of Alaska map that's going to be an online interactive GIS-based map to replace a really old 1983 geothermal map. So just for those who aren't aware, we have in Alaska we have springs that are hotter than 50 degrees C, 46 warm to cool springs. There's 36 that are out here in the Aleutian Arc, off the rest of it, but out here. 39 are in the central interior belt that extends from Seward Peninsula to the east. There's 4 over here in the Wrangell Mountains, which sort of are an extension of this volcanic arc system. And then there's 16 down in southeast Alaska. So this is what all this data looks like that we've put together on a map. Up here, all these different colors, they're color-coded from hottest to coolest. But those are bottom hole temperature data, and then there's some down here. We've added in, it's not yet on this map, but the Cook Inlet data. Here's the bottom hole temperature data out here. Then all the various hot springs, color-coded to their temperatures. Direct use of geothermal. There's one covered up by this one, but that's Manly Hot Springs. There's another one, Chena Hot Springs. And then volcanic vents, domes, etc. And then continue to go. So right now, currently, there's exploration and reevaluation from hot springs. Can you hear me?
Yes, we can.
Okay.
Yeah, we were getting a lot of background noise from somebody else online. Plus, you've been cutting in and out a little bit, Jim. So if you could maybe just make sure you're talking into the speaker or the microphone a little better. But we muted everybody just to cut out the background noise.
Right. Understood. Unfortunately, we're doing this over a cell phone because the state phones are down right now. Okay, so out of Seward Peninsula, there's Pilgrim Hot Springs. Chena Hot Springs is it's still exploring and using geothermal. There's a program underway for Mount Spur, which is right across from Cook Inlet here. Akutan, that I mentioned earlier. Makushan, that's the site of near Dutch Harbor. So these areas right now are currently ongoing geothermal exploration. And here's an example for Pilgrim Hot Springs. All of these boreholes that were done in the last several years and back in the 1980s, we've got all this data now into the NGDS. Akutan, they have an active exploration program. They were just drilling in 2010, and 2012 they did geophysics. This is an area where there's a fish processing site. Small village, but they have a high energy demand. And so they're hoping to find geothermal resources that can generate electrical power. And it's a perfect example. We wouldn't have gotten this into the system without the NGDS. We basically got in touch with the contractors out there. We got this April 2011 project report on these various hot springs and fumaroles out in on Akutan Island, which is out here on the Aleutians, and all this data is now in the NGDS, the core descriptions, and these thermal profiles that show the various appearances of alteration minerals at temperatures and depth. So all this information is now in the NGDS. So what we're doing is we're creating, this is kind of the culmination of all this project's work, is a new GIS-based digital online geothermal sites of Alaska map that's going to look like this, and you're going to be able to click on various spots like here at Akutan, and you'll be able to pull up like the descriptions. You'll be able to pull up water chemistry data, temperature data. Here's another one for Pilgrim Hot Springs, the aqueous chemistry. And of course, these right here are just the attribute tables from ArcGIS. But ours will be simplified and made more pretty. But we also want to have that you can pop up the Paul and Cummings diagrams for the chemistry for these sites too. So kind of the main important points that we've achieved with this NGDS project is it's allowed us to locate lots of new and old geothermal data, digitally store this data, and consolidate all into one single source. And this has just been a great improvement over scattered paper records. In the past, I've been asked, find some information. It would take me weeks to go dig it up, go try to find some report. So this has just been a fantastic improvement. The project, point number 2, is that it's increased awareness of existing geothermal information as well as highlighted areas where data is lacking. And I'll have to say, what this has shown is there's a lot of areas where research still needs to be done. A second aspect of point 2 is that we've been giving a number of presentations, and people come forward and say, oh, I know some information on such and such a geothermal site, and that's added a lot more new data into this. So it's just been an incredible boon to Alaska's geothermal. So I think we're right now kind of at the cusp where we're going to be finding a lot of people are going to be using this. People now are going to the geothermaldata.org site and downloading data. I'd just like to close this part of it, just thanking all these various people that have just been a tremendous help. The people at Arizona, Gwen Holdeman at the Alaska Center for Energy Power helped us get a lot of data, and then the rest of the people mentioned here. So that ends the lightning presentation portion, and we're ready for questions.
Great. Thank you, Jim. That's exciting stuff that you've got there. Very nice.
So I've just unmuted all the lines. I'd like to go ahead and open it first to the folks that have been part of this process since day one. So that's Rick, Lisa, and Dave. And
who are the members of
the Science Advisory Board, and see if they have any questions for Jim based on the work that was just presented.
Well, perhaps Rick Alice here. Perhaps I'll ask a question. So, have you got all temperature, depth data from wells all around the state? Are they actually in the database and able to be graphed or have been graphed with depth, temperature versus depth?
Which wells are you talking about? The geothermal wells, the bottom hole temperature wells?
All of them. Have you got gaps still?
Could you repeat the question, please? We can't hear you very well. We're going to cell phone here.
I was just querying whether, and it's actually a common question because this is some of the most valuable data, and I think as we're looking forward, the best effort initially is to look for whether there's some crucial gaps that need attention. So the question was, do you think you've got all temperature versus depth data into the system where you can actually see whether it's a shallow hole or a deep hole, the temperature variation with depth?
So the question is, do we have all the temperature variation with depth in all of the drill holes? Is that correct?
Yeah.
Yeah. Well, there's sure there's a lot more drill holes that we'll be able to do in the future. We have all of them, like from oil and gas. Well, we have experts. Right now, the data that's in there is uncorrected, but we are going to add into it corrected data, which is really important for the North Slope, where you have permafrost, which goes out to like 1,500 feet, 800 meters or so. And if you don't correct from the base of the permafrost, your geothermal gradient is going to be way off. So we're going to get all of that. And I think actually having this system up, this is the value of it, is that we're going to be able to find out where we have gaps in this data, and our efforts are going to be focused on adding to this data. So I can't say that we have them all now, but our goal is to have them.
And we have a lot of the little mining.
Right, mining, right.
And all the geothermal.
And all the geothermal wells that have been built.
All right, great. Are there any other questions from our SAB?
Well, this is Dave from Washington.
Go ahead, Dave.
I guess I would, some of these areas are pretty remote, and I suppose, like for the example that you used for like the Trident fish processing plant, the intent would be to use the geothermal on site. It's not looked at being any kinds of transmission, obviously, except maybe with around something like Anchorage or something like that. Is that something that you looked at?
Yeah, with respect to, that's one of the problems up here, is that where a lot of the geothermal energy is either nobody lives there or very few people live there. So for example, like the Akutan example, that would be strictly for the people of Akutan, which is a small village. And then there is the Trident fish processing plant, which has very high energy demands. But Akutan is an excellent example. That's probably the highest potential site in the state, and that could provide all the electrical power needs for Dutch Harbor, which a lot of people are familiar from the UV flow. Most dangerous sketch, the deadliest sketch. But Anchorage, they are evaluating that Mount Spur ORMAT is. They have a lease with the state, and so that could provide potential energy for Anchorage. And then the Pilgrim Hot Springs is being evaluated as a potential source of energy for the city of Nome, which probably, I think it's like, they're paying about $6 a gallon for diesel fuel there, roughly, and that's how their energy is produced. There is some wind power there, and they believe that Pilgrim Hot Springs will provide 2.5 megawatts of energy for Nome if it could be developed.
Thank you.
You're welcome.
Okay, great.
This is Arlene. Did I miss that? What in your first of all, thank you. This is a really great flash talk. Thank you so much. Did I miss in the geothermal sites of Alaska map did you show a total potential, or are there too many data gaps yet to come up with that kind of estimate?
We are not going to show a geothermal potential because that is kind of up to they're going to be able to use that map and put together their assessment of it. There's an old 1983 map that this is replacing that has some gray areas that what we call blobs. And the problem with that is when they put that together, they didn't really look at the, how it was going to be used, and it's actually been misused because people found a village someplace found that they lived in that gray blob and they thought they had geothermal potential when they really didn't. And our map's going to be similar to like the Nevada map, where it's point sources of data, and you'll be able to click on that map and come up with the, what is the data for that site. We're going to leave the geothermal statewide heat flow map type of stuff to like David Blackwell's group at SMU.